Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are checking your answers. You had quiz about pressure, paper 1 for core and extended candidates. Let's start by question number 1. Question number 1 is challenging question. You have a book of mass 400 grams. You have surface area or area of contact is given, can be calculated. Gravitational field strength is given. I will tell you why it's given now. What is the pressure exerted on the table due to the book? Back to our equation, the equation we are using to calculate pressure. Pressure is equal to force divided by area of contact. Okay, the force here exerted on area of contact is the weight of the book, so you are weight of the book. That's why I consider it as challenging question. You have to calculate the weight of the book first. Okay, and also the mass is given in grams. Usually the first step, you have to check that units are consistent. You have consistent units, so you have to convert grams to kilograms. You can divide by 1000 or multiply by 10 to the power of negative 3. Okay, how to calculate the weight of the book? Mass times G, gravitational field strength, divided by area of contact. So you have to convert first mass 400 times 10 to the power of negative 3 times 10 divided by area, which is 0.10 meters times 0.20. When you simplify, you can rewrite as scientific notation. So 4 times 10 to the power 3 times 10 to the power of negative 3 divided by 0.10 times 0.20. It's clear here, you can cancel out 10 to the power of 3, 10 to the power of negative 3. So your answer will be 4 divided by 0.02. Your final answer is 200 Newton per square meters. So the correct answer here is D. D is the correct answer. Question 2, here we are discussing pressure due to liquid. The diagram showing a stone suspended on a string under surface of liquid, and the question is asking you what would increase the pressure on the stone. What are the factors? Back to the factors. What are the factors affecting pressure due to liquid? Number 1, density. Number 2, vertical depth of liquid. Okay, for extended candidates, they know the equation. Pressure difference is equal to rho GH. Okay, so as the density increases, or denser liquid causing higher or more pressure, depth of liquid increases, also the pressure will be more. Okay, what are the choices we have here? Decreasing the surface area of the stone. No, this will not be the correct answer. Increasing the mass of the stone, this will not affect the pressure. Lowering the stone deeper into the liquid, yes, because in this case you are increasing the vertical depth of liquid. So the correct answer is C. Using liquid with a lower density. Density is a factor, but here the question mentioned the choice density is lower, and we are looking for increasing pressure. So lower density, decreasing pressure. Okay, so the correct answer for this one is C. Question 3. A man is in contact with the floor. In which of these situations does he produce least pressure on the floor? Kneeling, lying flat on his back, standing on both feet, standing on one foot. It's clear that according to the equation, pressure is equal to force divided by area. Here, weight of the man is the force exerted on area of contact, which is constant. So least pressure means increasing area of contact. In this case, increasing area of contact, it's clear. Lying flat on his back, area of contact will be greater. Okay? Question 4. The diagram showing a box of dimensions 6, 8, 4 centimeters as shown. The box rests on flat horizontal surface. On which face must the box rest to exert least pressure? Back to the equation, pressure is equal to force divided by area. Also here the force is exerted due to the weight of the box. Area, contact area, and pressure are inversely proportional. Least pressure means the area of contact should be greatest. Okay? We have to calculate in each case. In case if you place this on face X, on face Y, on face Z. If it rests on face X, face Y, or face Z. Before calculating area of contact in each case, I would like to show you dimensions. This 6 centimeters is also here 6, also here 6. Okay, this 4 centimeters here 4, also here 4. Okay, 8, you have here 8, here also 8, also here 8. Is it clear? Okay, let's calculate in each case. In case of face X, area of contact will be 6 times 8. In case of face Y, area of contact will be 6 times 4. Face Z, area of contact will be 8 times 4. Check your answers. The first one 48 square centimeters. The second one 24 square centimeters. Third one 32 square centimeters. You are looking for the greatest area. So the correct answer is face X. Question 5. We have a student uses her thumb to push a drawing pin into a notice board. The pin goes into the board but doesn't penetrate her thumb. Which statement explains this? If you look at the drawing pin, It has two, you have here large, somehow large surface, and it has sharp end. Okay, so she exerts pressure here, exerts force here, and this part is close to the board, to the notice board. According to the equation, pressure is equal to force divided by area. Which part of the drawing pin it has smaller area? Smaller area means greater pressure. Okay, so this part area of contact is smaller, which means it can penetrate the notice board and exerting more pressure. So the correct answer is D. The pressure of the pin on the notice board is greater than the pressure on her thumb. Question 6. We have here 4 teachers. We have weight of each teacher, total area of contact, and the question is which teacher experiences the least pressure. Okay, the total area of contact between teachers and nails and the weight of each teacher is given, so you have to apply direct application, substitute in pressure equation. Pressure is equal to force divided by area. Here the two factors are changing, so you have to calculate the first case. Here pressure in case of teacher A, so 700 divided by 13. Pressure in case B, 800 divided by 20. Although you have the weight in Newton and the total area in square centimeters, it's okay. Just here we are checking or comparing numerical values, no need to convert. Pressure C, 900 divided by 14. Pressure in case D, you have 1000 divided by 21. The correct answers or the final answers, the first one is 53.8 Newton per square centimeters. Second one 40 Newton per square centimeters. Third one 69 Newton per square centimeters. Last one 47.6 Newton per square centimeters. You are looking for least pressure. So least pressure means least pressure. Okay, you have final answers. You cannot consider least pressure is inversely proportional to area of contact because here the weight is not constant. If all teachers they have the same weight, you can consider it as a relation inversely proportional. Pressure is inversely proportional to area of contact. But here you have to compare the final answers you got. So, least pressure in this case, you have to choose the least pressure according to our calculations, which is 40. Okay, so the correct answer for this one is B. Objects with greater mass have greater weight. It's a correct answer, but it's not related to pressure. Okay, so weight is equal to mass times G, and greater mass means greater weight, right? If G is constant. 1 kilogram of water occupies more volume than 1 kilogram of lead. 1 kilogram and 1 kilogram, same mass, okay? But the volume will be different according to density of each material. But also this sentence is not related to pressure. Spikes on running shoes sink into the ground. Yes, this is related, this is relevant to pressure. Why? Because pressure is equal to force divided by area. So spikes here, you are changing the area in contact, which is decreasing area of contact, so means pressure will be more, which allow shoes to sink into ground. Water cooled to low enough temperature turns to ice, but also this is not related to pressure. Okay, question 8 is asking you which tube contains largest volume of water, and here you have different cross-sectional areas. Here it's not directly related to pressure, but it's good to recall or to remember how to calculate volume of water if you have a measuring cylinder or if you have different tubes. Okay, so volume here of liquid will be equal to cross-sectional area times height. If you calculate the first case, here you have area, cross-sectional area 10 times 6, which is 60 cubic centimeters, 20 times 4, which is 80 cubic centimeters, 30 times 3, 90 cubic centimeters, 40 times 2, 80 cubic centimeters. Which one here is the largest volume of water? Tube contains largest volume of water. It's clear that C is the correct answer. Why does this prevent the mixer sinking? Okay, so you have here large flat board, so you are increasing the area of contact. So increasing area of contact means less pressure. Pressure is equal to force divided by area. The force here is the weight of the mixer, which is constant. So when you increase the area of contact, the pressure will be less, so it will not sink in the ground. So the correct answer is A. The large area decreases the pressure on the ground. The last question, question 10, is very important and challenging. Okay, we have here 4 identical submarines, P, Q, R, and S, lowered from one depth to another. And the water here, it has constant density. Back to the factors affecting pressure of liquid, depth and density. The initial and final depth of each submarine are shown. Which row is correct for the difference in pressure? Okay, for extended candidates, pressure difference can be calculated using the equation rho GH. Okay, and here depth is changing, density is constant, so depth increased, the pressure difference will be more. If you compare, you will find pressure acting on submarine P, the depth changed from 10 to 30. So change in depth only 20 meters. For submarine Q, from 50 to 70, also 20 meters. Submarine R, the depth changed from 10 to 50. So change in depth here is 40 meters. And for S, from 30 to 70, also 40 meters. So it's clear that least change in pressure for submarine P and Q, and the largest or greatest change in pressure for submarines R and S. So again, the two factors, let's choose A, is the correct answer. The two factors are density, but in this case density is constant, so we are comparing depth and pressure. The deeper the object, it means the liquid above this object will be more exerting more pressure.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor.